Hi, let's continue with linear inequalities. We're going to look at compound inequalities. What are compound inequalities? Well, those are inequalities that involve the word and or that look like this. So here we have 5 is less than or equal to 2x minus 3 is less than or equal to 13. This is a compound inequality. It tells us that this expression, 2x minus 3, is between 5 and 13. All right. Now, the goal is as similar. We're going to solve these inequalities, meaning finding their solution set. And to do that, what we're going to do is treat this as a statement with 3 sides, as in we've got the 5 side, the 2x minus 3, and the 13. And we can work on each one all at the same time. So this particular inequality means 2 inequalities. So we have this 5 is less than or equal to 2x minus 3. That's 1 inequality. And we're considering this together with the other one, 2x minus 3 is less than or equal to 13. Right? And so we just merge them into one statement like this. Okay, so to solve this, well, what we would do if we just had this 5 less than or equal to 2x minus 3, we'd want to add the 3 to both sides. Right? It's the same step we'd want to take if we had 2x minus 3 is less than or equal to 13. We'd want to add 3 to both sides. So we'll add 3 to all 3 sides. We'll add the 3. Add the 3. Add the 3. Okay. So 5 plus 3 is 8, less than or equal to 2x minus 3 plus 3 would be 2x. And then 13 plus 3 is 16. Okay, and then we divide by 2, divide each side by 2, and 2 is a positive number, so we don't have to switch the inequality symbol, or we shouldn't. 8 divided by 2 is 4. 2 divided by 2 is 1, of course, and then 16 divided by 2 is 8. All right, so x is between 4 and 8. We can represent that with an interval, 4, 8, always the smaller number before the larger one. And then also we can represent this on a number line. So here's 4, here's 8, and we want to use brackets. There you go. And highlight the area in between. Okay. Let's look at this one. So here we have 6 times the quantity, x minus 1, is strictly less than 2 times the quantity, 3x plus 5, is less than or equal to 6x plus 10. Okay. So the first thing we want to do is get rid of these parentheses. So we'll distribute. So 6 times x is 6x. 6 times 1 is negative 6, less than. 2 times 3x is 6x. 2 times 5 is 10, less than or equal to 6x plus 10. Okay, now the goal here would be to get x by itself. And you can see that well, we're going to have a slight problem with that. We're going to have to subtract 6x from each side. And so we'll have negative 6 less than 10, less than or equal to 10. Notice the x's have gone away, and so we're left with just a statement here. And then so we'll need to read it and see whether it's true or not. So is negative 6 less than, strictly less than 10? Well, that's true, right? Is 10 less than or equal to 10? Well, yeah, they're equal. So since this is less than or equal to, this is true. So this whole inequality is true. Okay, what does that mean with respect to the original inequality? Well, since the x went away and the remaining statement is true, any x value could be plugged in there, and we would get the same situation right here. This means that all values for x, right, are a solution to this inequality. So we would write the solution set, negative infinity to infinity, all real numbers. or just the entire number line. Okay. Let's look at another example, an application of using inequalities. Here we're going to calculate what the student needs on her next test to pass the course. Okay, so in a class in which the final course grade depends entirely on the average of 4 equally weighted 100-point tests, Kelly scored a 95 on the first test, 85 on the second, and 74 on the third. What range of scores on the 4 tests will give Kelly a C for the semester? And here we'll denote a C as being between scores between 70 and 79 inclusive. Okay, so we can set this up. We know that the average of these test scores plus the fourth must be between 70 and 79 for Kelly to get a C in this course. We know how to calculate an average. Right? To find an average, we add up the scores and divide by the total number of scores that we have. So we have the 95, the 85, the 74, and a test that we don't know that she hasn't taken yet. Right? Divided by 4, the result of that needs to be between 70 and 79. So let's take what I just said and write it down as an inequality. All right. So first off, we need to write the average. Right? So let's write that down. We need to take 95 plus 85 plus 74 plus that test that we don't know. We'll call that x. Divide by the number of tests, 4. Okay, now this average, for her to get a C, must be between 70 and 79, inclusive. So we'll use non-strict inequality symbols. We'll put 70 down here and 79 up here. All right. Now, is this going to give us what we want? We have the average between 70 and 79. Whatever values of x make this inequality true will be test scores that will give Kelly a C for the course. Okay, so let's find this. What do we have here? Well, the first thing I see is a fraction. Okay? And we don't like those. We can get rid of those. We can multiply by 4, and that will give us 280 less than or equal to. If we add these together, $254 plus x less than or equal to 316. Okay, and now we can subtract 254 from each side. Here we have, looks like 26 less than or equal to x, less than or equal to, here we have 62, I believe. Let's like that. Yes. All right. So, x is between 26 and 62. What does that mean with respect to the problem? Well, that means Kelly needs to score between 26 and 62 on her fourth test to get a C for the course.